Let's be honest. If you've used Git for more than a day, you've probably run into that moment. You're about to merge a feature branch into main, and you hesitate. Merge or rebase? It feels like a philosophical debate. Some developers swear by rebasing, others say never touch it. So which side is right? Well, today we're going to settle this once and for all. We'll break down exactly what merge and rebase do, why they exist, and when you should use each one. By the end, you won't just know the difference, you'll know the real cost of choosing wrong. Welcome back to Dev Brief. First, let's start with the basics. Git is all about commits. You make changes, you commit them, and those commits form a timeline. But when multiple people work on the same project, timelines diverge. You have your branch, your coworker has theirs. Eventually you need to bring those lines back together. That's where merge and rebase come in. They are two different strategies for integrating changes from one branch into another. But here's the key difference: merge preserves history exactly as it happened, while rebase rewrites it. Let me explain. When you run git merge, Git creates a new commit called a merge commit. That commit has two parents, one from each branch. It joins the two timelines into one. The result is that the entire history is preserved, including the exact point where the branches diverged and where they came back together. This is honest. It shows exactly what happened, even if it looks a little messy. On the other hand, Git rebase takes the commits from your feature branch and replays them one by one on top of the target branch. It's like saying, I want my changes to look like they were always made after the latest changes on main. The original branch point disappears. The history becomes linear. Now, which one is better? Well, it depends on what you value. If you want a clean, easy-to-read history, rebase is your friend. A linear history can make Git log much easier to follow. You don't have to deal with merge commits cluttering up the timeline. It also helps with bisecting, because there's only one path to trace. But there's a catch. Rebase literally rewrites commit history by creating new commits. Those new commits have different hashes. If anyone else is working on that same branch, or if you've already pushed that branch to a shared remote, rebase can cause chaos. Other people's local copies of the branch become out of sync. This is known as rewriting public history, and it's a big no-no in collaborative workflows. Merge, on the other hand, is safe. It doesn't change existing commits. It just adds a merge commit. That means it's perfectly fine to merge branches that you've already shared with others. No one's local history gets broken. But the downside is that merge commits can make the graph look like a tangled mess, especially on large teams with many branches. Some people call it a spaghetti graph. And that can make code reviews harder, because you have to understand the context of those merges. So how do you decide in practice? Here's a general rule of thumb from the industry. Use rebase for your local, private branches that haven't been pushed yet. It keeps your commit history clean before you share it with others. Use merge for branches that are already public, or when you want to preserve exact history for auditing purposes. Another common pattern is to rebase your feature branch on top of main before merging it, but then do a regular merge to bring it in. That way, you get a linear feature branch history and still end up with a merge commit that marks the integration point. This is often called a semi-linear merge. Let's look at a concrete example. Imagine you're working on a feature branch that's 3 commits behind main. Main has new commits from your teammates. You want to integrate those updates into your feature branch. If you merge, you'll get a merge commit that combines your 3 commits with the new main commits. The graph will show the branch and merge. If you rebase, your 3 commits are replayed on top of the latest main, so it looks like you started working after them. The downside is that if you already pushed your feature branch remotely, you now have to force push it. And that force push can overwrite someone else's work if they also based their work on your old commits. Here's a common mistake I see all the time. A developer will rebase a branch that has been pushed to a shared remote, and they'll force push it without telling the team. The next person who pulls that branch will get merge conflicts that don't make sense, or worse, they'll lose commits. This is the #1 reason experienced developers avoid rebasing shared branches. Always communicate before force pushing. Another mistake is rebasing a branch that has many merge conflicts. If you rebase, you have to resolve those conflicts on each commit one by one, which can be tedious. With merge, you resolve conflicts once in the merge commit. So if you anticipate heavy conflicts, merge might be easier. What about the interactive rebase? That's a whole other beast. Interactive rebase lets you squash commits, reorder them, edit messages, or even drop commits. It's a powerful tool for cleaning up your branch before sharing. For example, you have 5 commits that are all small fixes. You can squash them into one clean commit. That makes code review smoother. But again, this should only be done on branches that you haven't pushed or branches that are strictly your own. Now let's talk about some real-world workflows. In open-source projects, maintainers often use a rebase and merge strategy to keep the main branch linear. Contributors submit pull requests, and the maintainer rebases them onto main before merging. This keeps the project history very clean. In contrast, large enterprise teams often stick with merge because they need to track exactly who merged what and when. Compliance requirements might demand that the audit trail is preserved. There is no one-size-fits-all. A good way to think about it is this: merge is for recording history, rebase is for polishing it. If you want to tell the story of how the code evolved, use merge. If you want to present the code as if it were written perfectly from start to finish, use rebase. Both are valid, but you need to know the consequences. Before we wrap up, let me leave you with a simple decision tree. If the branch is only used by you and has never been pushed, or it's a private feature branch you plan to squash anyway, then rebase is your friend. If the branch is shared with the team, has been pushed to remote, or is part of a release branch, then merge is safer. When in doubt, merge. You can always clean up later with an interactive rebase on your local branch before opening a pull request. And one more thing, many Git platforms like GitHub, GitLab, and Bitbucket offer a rebase and merge button right in the pull request interface. That's a great way to get the benefits of rebasing without the manual headache. But if you're using the command line, proceed with caution. Alright, let's recap quickly. Merge creates a merge commit and preserves the full branch structure. It's safe for shared branches. Rebase rewrites history, making it linear but risky if you've already shared your work. Use rebase for local cleanup, use merge for collaboration. Avoid rebasing public branches unless you've coordinated with your team. Remember, Git is a tool, not a religion. The best strategy is the one that works for your team and your project. Thanks for sticking with me. If this episode helped you understand merge and rebase a little better, hit that like button. It really helps the channel. And if you want more deep dives like this, subscribe to Dev Brief. We post every week to help you become a better developer. Until next time, happy coding.